Good morning, dear students. Welcome back to your another session of your lesson number 8, motion. Children, today is the fourth part. Before this, I have taught you about velocity, scalar quantity, vector quantity, and acceleration. Right? Now, children, today in our today's topic, whatever I will be explaining, it is totally based on the previous parts of this lesson. So anything you do not understand, please do not forget to give me your feedbacks or suggestions so that in my next class I can take those particular concepts once again. So children, let's start with the topic for today. Today we are going to study very simple concept, graphical representation of motion. Now children, whatever different concepts we have studied till now. For example, I taught you that an object may be in motion or at rest. So if it is in motion, how is it represented graphically? If an object is at rest, how is it represented on the graph? So that is all we are going to study for our today's topic. So children, let's start with the topic. We first come across distance time graph. First, today we will study about the distance time graph. Now children, distance time graph means on the x-axis, axis which is horizontal to the earth surface. In that we will be taking the time which is a non-variable component, and on the y-axis which is perpendicular to the earth surface is we take there our distance. Now children, the SI unit of distance is meter, the SI unit of time is second. Now children, when we draw a distance time graph for an object which is at rest, right, or for a stationary object. Stationary object means who still, who remains at the same time. Now when we draw graph for such an example, what do we get children? The distance time graph for a stationary object is straight line which is parallel to the time axis. So when we get a parallel line to the time axis, means understand that during that particular period of time the object was at rest. Now, distance time graph for an object which shows uniform motion. Now children, when graph is drawn for such a case, what happens? Uniform motion means equal distance in equal interval of time. So in this case, we get distance time graph for a uniform motion of a body is a straight line having a constant angle with the time axis, right? And with the help of this graph, we can find out the speed of a body. Now, when an object is showing non-uniform motion, how do we draw the distance time graph? Now, children, non-uniform motion means when unequal distance in equal interval of time, right? Time remains the same, but the distance covered keeps on changing according to the time. The distance time graph for a non-uniform motion is a curve, right? Now children, this curve can be towards the up, it can be an elevation or it can also be a depression, right? Any curve in distance time graph shows that the object is having a non-uniform motion, right? And having a increasing curve or a decreasing curve indicate that speed of the body may increase or may decrease. If it is elevation means if the curve is going towards upper side, then it is increasing. If it is going towards the lower side, depression, means it is decreasing. Now children, let us understand velocity time graph. Now, what is the difference between distance time graph and velocity time graph? Now, in distance time graph, x-axis time was there, y-axis distance was there. Now, children, velocity time graph means on the x-axis. Again, we will take the time, which is a non-variable component, and on the y-axis, we take the velocity. So, children, these are the three type of graphs that we are going to study now. Let us understand them each one by one. velocity time graph for a body moving with a constant velocity. Now, when an object is moving with a constant velocity, means in equal interval of time it shows equal velocity, right? So children, in this case, again we will get a straight line which is parallel to the time axis. Similar we got for also for an object which was at rest. But there the graph is drawn between the distance and time. Here it is velocity and time. Right? So children, uh, we can get such graph for all universal bodies. है like stars, planet, because their velocity never changes. But if we are in a traffic, if you are moving in a city, if you are walking or running, we may not get this parallel line. Now it helps to calculate the magnitude of displacement. It helps us to know that how much distance a particular object has covered. Now, velocity time graph for uniform motion when the body is at rest. Right? Right now, you must be sitting at one place and listening. Right? Now, children, let's say all of a sudden your doorbell rings. So what happens? You stand up and open the door. Right? So earlier you were at rest. So when you were at rest, your initial velocity becomes zero. Okay. So today we are going to study about such an object when the body was at rest initially. Velocity time graph for uniform motion body when initially the body is at rest. So again children, we get a straight line and an origin which has a constant slope. What is it used for children? It is used to calculate the acceleration and the displacement of the body. Now next is when the body was or is not at rest, right? Velocity time graph for uniform motion body when the body is not initially at rest. Let me give you an example of this. Now children, let's say you are cycling. You are going to some place with the help of your bicycle. Now you are already in motion. You are already in motion, and at the same time it starts raining suddenly. So what happens? You increase your velocity. You start pedaling very fast and start rushing to your home very quickly. So in this case you were not at rest. So here also children we will get a slanting curve, but it will not start from zero. Velocity time graph for a uniform motion when the velocity of the body decreases to zero. Let me again give you with an example. Like you are coming to Mithapur from Jamnagar. Now children, let's say that you are coming by the train. Now as the train leaves from Jamnagar, at that time your velocity was different. Slowly you come across different station and finally you reach Mithapur. So when you reach Mithapur, the train has to stop. Right? So earlier the velocity was very high. Now the driver applied the brake and the velocity of the body decreases to zero. Now here we will again get a slanting curve children, but it will be the upside one. It is used to calculate the acceleration and also the displacement of the body. Velocity graph for a non-uniform velocity of an object. If an object is having a non-uniform velocity, the best example for this is when you are on a car or when you are in a bike and you are crossing any city, right? So children, depending on the obstacle we have on the road, our velocity keeps on changing. If less traffic, more velocity. If more traffic, less velocity. And if it is a railway crossing, our velocity becomes 0. So in this case, we will get the curved graph again. So children, this was all about today's topic. I hope you have understood this. Such type of graphs are asked in the exams. So please be thorough with that. Which particular line shows what particular aspect of that particular graph. These graphs will be very much useful for you to solve the numericals, which will be the last topic of my lesson. So children, thank you and take care of yourself as it's raining very heavily.